So it's on Perceptron, linear regression, data gathering. Okay. Would you verify? Naalala niyo yung ginawa ko yung sa saging, yung nag-crop tayo tapos, may data tayo doon, right? Naalala niyo yun, yung kumuha ko ng,
Yes.
ito siya, banana ripe versus unripe. Mali talaga, hindi
Yes.
save. Dapat pala nagsisave ako kasi kung untitled lang, hindi niya save. Oh, nawawala dito. Anyway, save muna. Save as. Ay. Sige. Perceptron. Linear regression. Data. Okay. So, yung first section, gawa muna tayo ng set up muna tayo ng data. Kailangan natin yan. You can escape it. We need the data. Otherwise, artificial pwede, pero paano natin malalaman kung OP nga yung result niya, di ba? So, well, we do this again. Tapos gather tayo ng this is not how it's supposed to. Wait, let's get in. Wait. Yeah. So, okay, let's get 10 ripe parts and 10 unripe ones. Ito ba dito? So, wait. Let's define a very small window. Teka, let's just show the banana first. So give me a minute. Yeah. Run section. It is 554 by 800. Okay, so this is a nice batch, no? And we can select some that are very raw, no? They are a bit okay, and then some that are ripe. Tell you what, we can get 5 because I think there are 5 really raw bananas here, and we can get a bunch of ripe ones, and there are those that are in between, which is good, right? So we get ripe parts, unripe parts, and ripe bananas, unripe bananas, and test bananas. Okay, so we get 5 bananas. Okay, this will give us 5 times to click on the mouse. I click the image for 5 ripe bananas. We're gonna get a window via imcrop. Okay, in computing, it's best to specify the constants outside the program so you can easily modify it. Now we are gonna get rectangle. Let's define a rectangle area to be width equals 10 pixels. Height equals 10 pixels as well. Okay. We're gonna crop a rectangle, which is x minus w. Kung naalala nyo to, I hope you do. This is the way to specify the rectangle that you will crop automatically. Okay. When you define a rectangle, you give the upper corner, upper left-hand corner, which is xy, and we want it to be at the corner of a 10 by 10 box. So we're going to subtract width over 2 minus height over 2, and then you give the width and the height. Okay. So this will run for 5 times. But what we want to happen is not going to save the image. What we will actually save are what we're going to save is the color. Okay. So the first color would be, so that would be our feature. Let that be our feature, the RGB. Okay. So let's call that C. And it will be the average of, and there would be 5 of these C's. Oh, let's call that R for ripe. Wait lang. R. We now have a J, and we want that J to be I. Okay. All right. So we want that to be the average of J. Now, let's say that's mean J. But in what dimension? We have to figure this out. Oop, may natanggal ba? Who's that? Okay. Hello? Sino yung nawala? Is she back?
Yes.
Yes.
Yes, ma'am.
All right. Was it like this? Can't remember. Sige, go. I think we have to do it in the second dimension. This should be 3 by 5. In the end, this should be 3 by 5. Meaning the 3 would be the average color, RGB. Okay. This would be a 10 by 10 by 3. Oh, it should be, I think, by 3. The third dimension. Okay. Okay. So this is something like this, but 10 by 10 by 3 because of the RGB, right? Okay. And we want it to be confined to a number between 0 and 1 because for networks, it's more manageable to have a number with around 1, not, you know, a large number like 2 by 5. We may need to double this up because we're taking the mean as well as dividing by 255. So I suppose we have to envelope this with a double to convert it from an unsigned integer 8 into a floating point number, a real number. Now, I'm not sure if this will work, but let's give it a go, and then we will correct. There are things that I'm not sure of, like, is this correct? Will this allow us to get the average RGB? Will this be 10 by 10? I'm not sure. Okay, wait, anyway, let's, to limit this, let's have just two numbers muna. Testing pa lang naman. Okay. I think we should put this here. Control X. Okay. Right. Let's just test this muna. Transaction. Now, by asking for a G input, it allows you to click the mouse, and you see here the arrow. One. Okay, I want 5 of those. Ay, right pala dapat. Pero anyway, test pa lang to. 2, and that's it. Unable to perform indice assignment because the indices on the left side are not compatible with the size of the right side. Okay, I'm not getting a 10 by 10. Instead, I'm getting an 11 by 11, but that's fine. But at least we have only one J, but that's fine. Okay, let's check this. How do we get, let's see, what happens if we take mean J3? Oops, the answer is 11 by 11. We don't want that. How about 1, 2? Okay, let's see what happens here. Yun, this is what we want. Meaning we're going to average along 1 and 2. And right. Okay, how do I know that this is correct? Because look, 109 is red, 135 is green, 24 is blue. Now what I picked up earlier was a greenish banana. Look at the green. It's the highest value. And red is also high. Why? Because if red and green are high, it means medyo yellowish siya. Okay, so it might be because there's a bit of yellowish tinge, but the fact that the blue is not, is small, means parang correct yun nakuha ko. Now, if I'm gonna press something yellow, medyo dapat, medyo mas pareho yung value nitong dalawa. Let's try this again. Okay, now I now know that I should say the dimension should be taken around 1 and 2, second and first dimension, which is the X and the Y. Let's see if it works this time. Now I'm going to get some yellow parts. Okay, so let's get some ripe banana, shall we? This is in the shade. I remember someone was asking, was it you, Adi, who asked, Ma'am, paano kung it's in the shade? And I said, well, you take it in RGB. All right, there seems to be no error now. And let's take a look at our R. Hey, I like this. We have 3 by 2. And it's already normalized. So let's inspect this value. Okay. All right. Red and green and blue. So this makes a little bit of sense. Mas mataas yung red kaysa sa green, pero medyo pareho pa rin sila. I mean 7 and 6, 8 and 6, yeah. Okay. Tas mababa pa rin yung blue. So this is realistic. This might be okay already. And so we are now ready to have a selection. So R is for ripe, and we will repeat this. Copy. Where's your copy? Copy. Edit. Ang copy. Friend. No, copy. Control C. Control C. Click. Control B. Wait. Okay. We're going to use the variable U for the unripe. And then arbitrarily, we're going to get some test images. Okay. Let's set it again. Control B. Command. Okay. Okay. We can also make this another section break for when we want to make some tests. So I'm gonna put some key for test. Oh, what? No, T. Then I'm gonna put sabi na T. Wala lang T equals. Wait, hindi. Mamaya na natin ito gawin. Runs insert section break. We'll just skip this. We'll make another section break because we're gonna now, after having in memory these ripe and unripe, we can now make the linear regression. Meanwhile, let's run this and let's plot their RGB in feature space. How about that? Sige. So I'm gonna plot in 3D because they have 3 values. Let me see if I can do that. 3. Let me see. Let's try first. I'm not sure if this will work. Plot 3 ripe. Wait, have I already a ripe set? Dalawa. Okay. Ripe. So I will try first to plot this because I already have a set of ripe values. I want to see if it will plot in 3D. Now, let's plot it this way. Let's see what happens. Not enough input arguments. You want me to be explicit, Be? Okay. Okay. The first would be 1, the red, and for all points. The second is the y-axis would be the G, and the third axis would be this. Okay. So I'm gonna plot in 3D the RGB of the two points. So this is RGB space. So let's have a look how it looks in RGB space. So ito sila. And I think now I can do that. So let's figure 2. I'm going to plot R. Copy this. Control C. Control C. Control V. Okay. Now there is a function hold on which allows you to plot the next set of data on the same plot. So I'm gonna repeat it for the unripe set. Okay, so U and U. But now let's so this is yellow and this is unripe, so let's call it the green, and then it's gonna be X. Okay. All right. And then you turn off the holding so that you can plot elsewhere now. All right. So this opens the image. Well, this one gathers data. Let's say, bigyan natin siya ng title. Sige, try natin to. So remember please that first I'm gonna plot ripe. I'm gonna click 5. Oh no, kulang 5. Dapat dumihan natin 5. 5 bananas that are ripe and 5 bananas that are unripe. Okay. All right. So let's clear this first. And then let's clear this too. Clear input. Okay. Now let's clear the workspace to erase all variables will be deleted. That's fine. It's okay. You can start again. All right. Let's put this at figure 1. Okay, it will pop out. No? So let's run this section and it will open a separate window showing the image. There. Go to figure 1. Anyway, now please remember ripe first before unripe, okay? So now let's run this section and the G input will allow us to click 5, 5 ripe and 5 unripe banana points. Okay, run this section. So, ripe muna. Okay, let's say this is clearly ripe. 1. And then let's have another this. 2. And let's have another here. 3. Where else? Say this one, perhaps. Maybe this one. This one looks right. 4. Where else? This one looks right. 5. Okay, I think, was that 5? So now I go to unripe. This is 1. 2. 3. 4. Ano, this is ripe or raw. Ano sa inyo dito sa ano? Ito na lang. Sa taas. Medyo hilaw pa nga. 5. There. So we have ripe, unripe, and we're supposed to see a plot. The plot goal. Was there an error? Oh, this is it. Ang liit naman. Ano ka ba, te? Bakit ganyan? Pop out ka nga dyan. There. Nakikita nyo ba? Labo naman ito. Wait lang ah. Bonggahan ko lang. No. Anyway, nakikita nyo ba yung yellow? Masyadong liit. Liit. Baka pwede kong i-edit dito pa man. Pakapalan ko lang. Yan, line style. Line width. Walang mabes. Tapos, color. Palitan natin yung color. Masyadong mababa. Okay. Yan. Okay. Now, you can see here that Okay naman yung green, no? Okay naman yung green. Ayan siya. Okay. Okay. Diba? I mean, if you rotate this, guys, diba, medyo kikita nyo, you can put a plane between the two, right? And say, okay, this is separable. Obviously, it is separable. I can put a decision plane between the two. But just remember, this is ripe and unripe, okay? So, teka, so, na tayo dyan. I want to rotate view. Rotate. Rotate na. Ay, nakikita nyo, nag-pop out yung rotate. Ayun, rotate rin. Yan. Okay, rotate. Ayun. See the two, no? So, XYZ is RGB, and obviously the ripe and unripe are separable from one another. All right. Now we have our data. Now we can start creating a perceptron or linear regression. So first, let's define a training data, which is a combination of the ripe and unripe. Yan na, pareho lang halos yung steps nila. Uy, ano yan? Ba't ang laki? Ulit ako dyan ah. Pinakalaan yan ah. Bakit na ganun? Hindi ko alam bakit bigla ka naging ganyan. Anyway, alright, let's first define the desired. The desired array is ang kapal. Ba't ganyan? I don't know. Okay, D is the label. So, kailangan nating lagyan ng label ito. What is the label? It can be 1 for ripe and -1 for unripe. Okay? So, since the first 5 would be our ripe, let's say this is 1. This is 1, 2, 3, 4, 5. This is our ripe. The succeeding 5 would be our unripe. So let's say this is -1, -1, -1, -1, -1. Okay, so this is our label vector. This corresponds to a training set, which is equal to the first is the ripe, and it will be R. So all the in R, and then 3 by 5 to, no? Tapos idudugtong natin sa kanya yung U. U. Okay? And remember, look guys, close na muna natin ito, please. Okay. This is an important part. You're preparing the data. In some applications, the data is already prepared for you, but since this is part of your activity, I'm showing you how it can be done. This is a matrix, and then you concatenated it with another matrix U. So 3 by 5, 3 by 5, dinugtong mo sila, it's going to be supposed to be 3 by 10. So if we run this section only, yun, tama, 3 by 10. Now we're ready. So our data is prepared, and now we can do the perceptron. Sa perceptron, okay. Ay, sorry. Bea, you were asking for 8, not for 9?
No, it's okay. I realized 8 is manageable. It's actually better.
8 is easy. I mean,
Yeah.
it's step by step easy.
Yeah, it's easy.
User's manual easy, promise, di ba?
Yeah.
Okay. Okay. So first, di ba, we need to perform this. multiply inputs xi to corresponding synaptic weights wi. Ano yung synaptic weights wi? We randomize. We give it an initial random weight. Okay, so our w's would be random numbers. All right, but please don't forget that we have to have one extra bias neuron, and this will take care of any constant bias that may be present. Okay, ito. Include a constant bias x naught equals 1 in all sample inputs. Thus, a 2-feature vector will become a 3. All right. So the first thing is we have to insert a bias. Balik tayo doon. The labels will not change. But we will make this, instead of 3 by 10, we have to make it a 4 by 10. No? And kumbaga, kasi RGB na to eh. RGB, right? It looks like this. Right? Okay, if you look at it, it looks like that. Now, magdadagdag tayo ng unang row na puro 1 lang yung value niya. Okay? So, how do we do that? Okay. I'm gonna write t again and equals. Teka, paano ba? You know that you can generate ones this way. So I want 1 by 10 set of ones. It's gonna look like this. Okay. So I'm gonna say t equals ones (1 by 10), and now to go to the next row, I'll put a semicolon. Go to the next, no, not that literal. And what you put there is t. Now I'm going, parang pumapatong ako sa t, no? Let's see if it goes. Oh, in fact, we can do it this way para isang usapan na lang. Okay. Ones, 1, 10. Okay. And then I say semicolon R and Q. There, that should work. Okay, so I'll erase this. Let's test it again. It should be now 4 by 10. Indeed it is. And if we hover our mouse, you see that, yeah, na-insert natin yung ones dun sa taas. Okay, so now that our desired output and training input are already ready, we now initialize weights. So since our input is a 4 vector, no? A 4 component vector. So our weights should be as well 4, no? And it's gonna look like this one, pero 4. Okay? Which means dapat meron tayong 4 weights. Not 4 by 10 weights, mind you. 4 weights lang. And those weights are the ones that we need to optimize. Okay? Kasi ganito nga itsura ng ating network. Ito lang yon, isang perceptron lang. Okay? So that means we just need to find the value of the 4 weights. And so we're going to initialize the weights. And W, let's call that W. And it can be a random number. And again, it's 4 by 1. Ay, hindi ko sure. Tingnan natin. W equals, this is a nice place to test it, 4 by 1. Yes. Yes. Sige. All right. So what's the first step? After the initializing, we now can loop. Again, you learn by experience. You learn by always looking at or hearing the lyrics over and over again until you memorize it. Parang ganun rin ang network. So the first iteration would be, we will send it a data, multiply it by the random weights, have them multiply, get the that product. And then we will, after getting this sum of weights times input, we're gonna get A, we're gonna let it pass through an activation function. And then that's the output. And whatever output that is, we will compare it with the desired output. Ito siya. Okay. All right. Ito na tayo. Include the constant bias in all sample units. Check. Okay. Let DI be the class label of the feature. So 1 yung isa. So ripe. And unripe class is -1. Okay. Initialize the weights. Check to some random number. Note that X naught will have its corresponding weight. Opo. Okay. Calculate the perceptron output as in steps 1 and above, meaning xi times yi, the sum. And then we will apply Z. Once we get an output, we calculate the weight change rule as some eta. So we have to define our eta. Let's give it an eta. No? We have a desired output. We have a network output. And for each of the samples, we multiply. What is X? This is the ith sample and the jth component. So each of the weights, the jth weight will have weight change value. All right. And once we compute this weight change value, we will modify the weights. The old weights will be added with this weight change value. And then we repeat and repeat and repeat. Okay. Okay, let's go through that. So ulit. Meron na tayong na-initialize na weights. Minsan lang yan, ha? Okay. Now we need to compute the network output. So here I'm gonna call it compute Z. So Z is just one value, remember? So first, we multiply each of the T's with the weights and we sum them all up. And notice that it's matrix multiplication. Okay? So parang, tignan nyo ha, T is 4 by 10. W is 4 by 1. So we can go T transpose times W para yung 4 and 4 nila pagtugma. Okay? And because of this, we will have 10 outputs. Okay? Right? 10 outputs right away. Bakit? Kasi 10 yung samples natin di ba? Tingnan nyo ha. So this is the Z. Tingnan natin kung tama yung calculation ko. We get 10 outputs. The answer is there, 10. 10 by 1. Ito na yung Z. Then, each of these, we will apply a since a G. So, we have to define the function G. So, una muna, ito yung tinatawag na A. A is T transpose times W. Are you with me, guys? Ito pa lang yung A. And this is for each of the samples, okay? Then we calculate C. Okay. Ano ba yung C? Ano sabi natin sa C? C is a function 1 if A is greater than or equal to 0, -1 otherwise. Okay. All right. Okay. All right. Z equals ano nga ba to? Paano ba to? How do you make a function? Wait lang ha. Okay. 1 and -1. So there must be an easier. Pero anyway, ayoko nito, but this is a rough and dirty way to do it. If A greater than 1, Z of I equals 1. Else Z of I okay. So let's try A of I. There would be an easier way than this actually, because this is matrix operation. Shall we try this? Okay. Section. Okay, let's have a look. Ano ba yung mga nakuha mong 8? Yun, tingnan natin. Meron nga siyang, ay ano ba, greater than 1 ba? O less than, ano ba yung sabi dun sana? Parang may mali. If A positive, ay mali, joke. If A greater than or equal to 0, hindi pala. Mali. Hindi negative po naman. Positive. A ulit. Sorry. Ulit. Transaction. Alright. Tama kaya? Tignan natin. Okay. Tignan natin yung A. Lahat ito, puro positive 1. Greater than 1, ano? Tignan niyo yung pinakadulo. Tama, ano? Ay, itong nasa taas, kasi may pinatungan siya earlier. No? So, pinakikita lang dito. Pero, as you can see, ito yung huli na. Ito tama, right? Because all of the A's is greater than 1. Okay. So, hindi lang natin na-suppress yung output. Suppress natin yung output, but that's okay. Okay. Na-compute na natin yung Z. Now we have to compute the weight change. Delta W. Okay. And the delta W is equal to eta, desired output, which is our D, minus the network output Z, times X. And this X is yung input natin. Okay. For the initial iteration. And this is J, no? And this, remember, this is 4 by 10. This is 10. Diba? This is 10 by 1. Diba? Basta 10 ang component nito. This is just a vector, but this is a matrix kasi marami sila. And we have to define an eta. Okay. So Davidon, we have to define an eta. Eta. This is our, it looks like an n, ano? But sige, it should be a number less than 1. So let's say 0.25 muna. Sabi to, EW is equal to eta. This is the learning rate, no? How fast you want it to learn. It sometimes is something that you need to tweak. The D is 1 by 10 and the C is 1 by 10, so that's fine. So D minus Z. So this is a 1 by 10. And we have to multiply it by X. What is our X? Our X is 4 by 10. So we have to make the 10 coincide with the 4. Or we can do it this way. Anyway, pareho lang naman to. T. Unahin natin yung T. And then matrix multiply by eta times DC. Okay. Imagine this. This is 4 by 10. And this is going to be 10 by 1. And therefore, we can 1 by 10? No? 1 by 10? 1 by 10? Okay, transpose na natin sila para 10 by 1. Okay? Ta-transpose natin sila. And therefore, the matrix multiplication will be behaved. Okay. I'm so confident about this that I want to run this right away. So I'll run this section only. I can do that. Instead of going through here, I'm done with that. I can just test this to see. We expect this to be 4 by 1. Okay, evaluate selection in command window. Okay. Nga pala. Hindi pa na-define yung eta. Okay. Sige po. Hindi pa pala natin na-run na sa... Yan. Yan na. Alam mo na ako ano yung eta. Ulitin natin to. Select that and run that. And yes, now I have 4 corresponding to the weight. So this is what I will add to the initial weights. Okay. So what we do is update the weights. So the weights W, which is 4 by 1, will now be W. Wait, may kulang pa, girl. Ano ba? Hindi, T. Ito na yung X natin. Ito nga pala yung X natin. Ito yung X. Ito yung ito. So, essentially, ito yon. Here is ito yung X. And so that para mabilis, ginawa natin matrix multiplication to. No? At ito yung eta DC. Okay? So, in one fell swoop without making loops, nakuha na natin siya. Alright. So, gagawin natin itong weight change. And we will iterate lang. So, W. That's it. Okay? Tapos, uulitin lang natin to. Ito. Siyempre, hindi dapat natin i-initialize yung weights, no? Kasi, otherwise, nabubura natin siya. This initialization of weights happens outside the loop. Now, I can either stop this in 2 ways. We let it run and run and run until D minus Z is less than kasi dapat equal na sila eventually, no? So D minus C should be equal to 0 or some or less than some tolerance. Okay. So I can do that. While mean of D minus Z. Average, alam mo kung bakit? Kasi 10 yan eh, di ba? Is less than a tolerance. Now let's define the tolerance. Okay, this is a while loop. So this will repeat this, all of this. Okay, until this tolerance or together tolerance. What would be a tolerance? Our tolerance will be 0.0001. Yan lang. That's our proxy for 0. Okay. Ano na nga ba yung while loop? While. Hanap tayo ng documentation ng while. Sample nga dyan, please. While loop. Okay pa kayo guys? Nasusundan niyo ako? While this, tapos may end. Okay. Sige. Try natin yan. Hindi lang pala. Kailangan lang ng end. While mean is less than tolerance, do this, and then all of that will end. Okay. Tama. So, i-tab lang natin siya. Tab lang natin sila. Para mukhang sexy. Ay, sobra te. Sobra. Loop na ito ay dito. Okay? Then, we come to update the weights. Okay. So, ang desired natin is the Z will copy the D. In which case, ang mangyari nun, then it would have train. Okay? Alright. Let's see if it works. Let's run this. Okay, now it's running. Is there an error? Is it done? I think it's done. Okay. Well, seems to be done. Does it say it's busy? It doesn't say it's busy. I think it's done. Okay, let's check. How do we know if it's really done? Let's see the Z. The Z is the network output. Did it work? Let's check. Basta na po yung Z natin dyan. Z. Hala. Puro -1. Hindi po. Dapat 1, 1, 1, 1, 1. Tapos negative 1. Teka, mali yata. May mali tayo. Teka. D minus Z. Ano ba yung D minus Z natin? Ay, joke. Right. Bakit yung... Okay. Alright. Ano yung mean? Ay. Teka. Hindi ata siya tama. Wait lang. Teka. Tayo. Ano nga po uli natin? While statements. Teka. Problema ako. Wait lang ha. Tingnan natin to. Okay. Run lang. Run lang ulit. Run ba siya? Run section. Run section. Hindi yata siya nag-run. Ulit. Run section. Run section. Nakapan ako dito guys. Hindi nagbago yung DW. Wait. Wait. Mag-initialize ulit tayo. Mag-initialize siya ng weights eh. Okay. Ano na uli yung C? Wait. Anyway, imbis na while, try natin to. For loop muna. For J equals. Let's run it for, say, 10 times. Okay. So this loop will run 10 times. Okay, let's hope for the best. Okay, run section. Ayun, at least nagbabago. So let's have a loop. Nagbabago. It will run 10 times. You will have 10 values here, but it settles at this. Okay. As you can see, change siya, no? Minsan all negative, minsan all positive. Is the weights changing? Well, para siyang nag-o-oscillate lang sa 9219. Alam kung bakit. Palitan kaya na itong. Okay. Ano natin yung nangyayari sa Z natin? Nangyayari sa Z. Ganun pa din. Let me see. Okay. Okay.
My Z changed na, but I don't know. I just followed you though.
Yeah, if I press Z, it looks like this.
It's the indentation in your for loop.
What about?
Right, the else should be pantay with the if, and the end. The two ends shouldn't be pantay.
It recognizes that they're connected. Have a look. Kung ito, pwede naman. In Python, it matters. Pero ito na rin.
Okay.
Like if I press this, na-recognize niya na these are the ones that are connected.
Oh.
And this as well is connected to that end loop down there. Diba? Notice?
Okay. Oh, I see. Okay.
Okay, I'm gonna do something na ano, no, kasi the weights are all positive and this is all positive. Teka. Para magkaroon ng negative value yung weights, i-randomize ko siya to plus or minus 0.5. Sa ngayon kasi, wait, let's look at W. This is now what W has changed to. By the way, this can take some time. This may need to be modified. Anyway, let's try to think. We can minimize this a bit, some more. It can happen minsan na mataas masyado yung eta. Then we can, the weights here, have a look. The weights have now modified such that mataas na yung pangalawang weight. Have a look. No? If we run from here to here, let's see if we initialize. ito na muna. Another way of running this is, say, I go here and select all these and then evaluate lang ito. And then let's inspect W. Okay, have a look at W, no? Ito yung value ng W sa ngayon. 0.655, 0.17, 0.706, 0.038. Okay. Now let's run the rest of this. All right. Let's evaluate. And again, the DWs will scroll. But I think it's done. Is it so? I think it's done. And we have seen that the weights have now changed this much. Okay. And naging negative na iba, naging positive yung iba. Then we can take a look at what the Z is. All positive naman. But that's actually that is promising kasi all negative kanina. So now I'm gonna run this for 1,000 times. See, this is another free parameter that we can do. Ideally, dapat patakbuhin natin to until D minus Z is less than the tolerance. Ilang nga kanina, parang nakuha kong D minus C. Di pa ata enough yun. But anyway, let's just run this 1,000 times, shall we? Okay, so I'm gonna run this section again. Run section 1,000 times. Oh, by the way, it's showing all of these DWs. Let's suppress that by putting a semicolon. Okay, after 1,000 times, sige, let's inspect the Z. Run section. I think it's done. It's not fast. Is it done? What's J? Let's take a look at the J. Oh, it's already done because it has looped for 1,000 times now. Okay, how's the Z doing? Oh, look at Z, guys. Have a look. Nakita niyo yung Z? That's the output of the network. Now it matches the D. Oh, look, we have trained our network. We only have to be patient. Did you see that, guys? The network output has now been able to copy the desired output. Okay. Ideally, you should run this only up to the number of times needed to get into the tolerance. So let's look at the W's now. The W's are these. Okay, the W, please. So now we have a set of weights. We can actually try and test this now, actually. How do you test? You now have the weights. By the way, you can also display this line because we're looking at the perceptron, no? Sabi dyan, once you have the W's, no? Using your take 2 classes at a time computers, plot your data in feature space, and we did that in RGB space and overlay the decision line. In this case, it's a decision plane. So we have to convert all of this. Kung sana 2D lang yung data natin, we could have done this. But if it's a plane, we have to replace all of this process by the equation of a plane. Essentially, once you have the weights, find the corresponding coefficients for the equation of a line or a plane, and then plug in the final weight values, and then plot your plane or plot your line. Again, this is in 3D, so it's hard to draw. We have to do the math first, but we can actually try and test this now using data from the same. Right now, let's test. Okay, to test, we will click a portion of the banana, and it should tell us. It will calculate this again. Essentially this function here, okay, and then tell us if it's ripe or unripe. Now, normally, ang gagawin nyo, just to test how accurate your network is, you should have also a test set. Okay? And in this test set, you you also have desired output, or rather labeled na siya. So for example, in this test set, you have also 7 ripe, 3 unripe, no? And their corresponding RGB, average RGB, and label, okay? Since the weights are already computed, all we have to do is calculate this with the final weights in the T, which is the average color coming from this. And then calculate this. And then see kung ano yung Z niya. Is it ripe or unripe? Okay, sige. All right. So since this is a test, we can just set our test numbers into whatever we want. Say 3 para mabilis lang. Okay. Okay. So, hindi natin papatungan yung R. So, tatawagin natin tong test. Okay. So, and then, we will fashion the value again like this. No? There should be 1. Okay. And then we simply do this. Copy this. Anong copy dito sa ano nito? Control C. And be sure to call this test. Okay. And para hindi mapatungan yung Z. Okay. That's it. All right. Then we will ask that Z be displayed by just pressing Z here, and it will display. So, essentially, this repeats getting 3 test points. Just remember kung ano yung label nila, no? So let's first, for example, let's see, let's pick the first 3 ripe. No? Kuha tayo ng 3 ripe samples. Tingnan natin kung 1 or -1 lalabas niya. No? So dapat kung tama yung network natin, 1 lalabas niya kung ripes, all ripes yung 3. Okay? Sige, let's run this. Okay. Yung show I ulit tayo just in case kasi nawawala na yung I. Okay? Alright. Right. Let's run this. Run section. Okay. Let's pick another 3 ripe bananas, shall we? Where's my G input? Okay. Uy, hindi ko makita yung arrow ko. Patay tayo dyan. Hindi ko makita yung... Hindi lumalabas yung crosshair. My goodness. Wala nga, hindi lumalabas yung crosshair. Malaking problem to. I-figure nga natin to. Wait, Control C. Stop. Stop. Figure 1 ulit natin to. Okay, ulit. Sana lumabas yung crosshair. Run section. No. No. Wait. Mahirap na to. Hindi ko makukuha to. Okay. Patay tayo dyan. Dapat siguro, sinama na natin dito, no? Yung test. Kukuha tayo ng test samples dito. Gawin nyo na lang yan, guys. Pero, wait. Saan ako? Ba yan? Pwede bang mag-pop out? Guys, hindi ko mapalabas yung mouse ko eh. Paano ba? Kailangan natin ng crosshair dito kasi hindi lumalabas yung crosshair. Hindi natin matetest to. But, can you do the test yourself? Guys, can you do the test yourself? So, sa linear regression, so kumbaga, now you have the code, no? I would recommend that when gathering data, you have ripe, unripe, and test bananas. In the test bananas, just pick a few random ones, but label them properly. Like, you have to have the D for that corresponding test set, okay? And then, once you have them, you just run this and observe if the z-test output matches the D or the label, the desired output. Okay ba, guys? Hindi ko maano eh. Tingnan nyo, oh. Hindi to eh. The crosshair is not showing up. I mean, I don't know where I'm pointing at. Diba? So medyo fail. Pero that's it. And how do you do linear regression? Easy. Or logistic regression. You simply change Z, Z into the logic function. Ito, 1/1 plus exponential minus beta A. Yan. And this beta is something that you can control. You can set that. Okay? All right. Tapos, wala namang desired function. Walang desired function dyan. It will just squish it. Okay? Tignan nyo, oh. The desired, nandyan yung desired, 1 minus. Pero yung z natin is a continuous function. I mean, it's not just 1 or -1. It depends on this value of phi, no? Do you understand, guys? Okay, so the desired function is still there. Desired number is still there, 1 and -1. And z is still there, same. You just have to replace z here. Ito. This is the z function, right? So if ito na, tatanggalin lang natin to. Lalagay na natin z is equal to phi of a. Phi is 1/1 plus exponential minus beta of a. That's it. All right? And that would be your value of c. It's a number between from -1 and 1. Then follow through. Ito pa rin. Do you understand? Yan in the testing. Papalitan mo lang talaga to. This is the z function. Okay? Itong 8, pareho pa rin yan. Pero yung z is according to the logic function. Okay? Malinaw ba? It's 10 and I have to go. May lakad ako. May tanong ba? Did you get it, guys? Ha?
Yes.
I hope so. So, sayang hindi lang natin napakita yung test. Kasi hindi ko makita yung mouse eh. Kung makita lang sana yung mouse ko, we're sure na, okay, this is ripe, this is unripe. Okay. Okay. Sige, we're done. That's it. Did I press record? Did I remember to press record?
Yes, ma'am. You're recording po.
Okay. Okay, I'll stop share here. Okay. Hey, Carl, how are you? Okay, so that is it. And you learn 3 things from just this activity: how to gather data. Although in the future you might not need that because most of the data sets are already available. But in case you need it, you now have a way of doing it for images. Activity 8 also allows you to get data automatically, okay, for several samples, arranged samples. Besides being able to get data, this section also taught you how to compute a perceptron and how to modify this C function here para logistic regression. So logistic regression, you don't get 1 minus 1. You get a number between minus 1 and 1, or sorry, 0 and 1, which tells you the degree of ripeness. So ibig sabihin, kung dapat pag pumili ka ng maniba-niba dyan na that will give you a number between 0 and 1, maybe near 0.5. But if it's unripe, it might be 0, near 0. And if it's ready ripe, it would be near 1. And if it's in between, it will give you the degree, like 0.7 or 0.3. So that's what's nice about logistic regression. It's not a hard yes or no, ripe or unripe, but it says 70% ripe. Okay? Yun lang yung kinaiba nila. But same functions. Same procedure. Okay? Okay. You still okay for a meeting next year para just in case you tidy up some odds and ends for some other activities that I'll be giving you. I mean, okay, just last question. So next year pa yung last day of classes natin, January 6. So technically, I still have 1 week with you. I've just posted SBM and there are 2 remaining activities, which is neural network and CNN. They are rather very involved, okay? Meaning medyo tough sila, but it can be done once you know how to make a perceptron. Now, I'm open to your suggestions. I can post those activities before the Christmas break, and maybe you can try them. But is it okay we meet again first week of January for any tutorials that you would like?
Yes, ma'am. It's okay with me.
Not the rest. Sige.
Yes po.
Okay. Okay, so 187, done na tayo. We don't need to meet, okay? Just give me time to post the videos of the tutorials. Although, yeah, if you still have any struggles with 187, still open to tutor you. And here's a bonus. If you feel bored during the Christmas break or you feel anxious during the Christmas break because you don't know how to answer some of the activities, give me a message. I don't care. I mean, sure, I'm fine with that. I get bored too. So, anong gagawin ko? So, magkwentuhan na lang tayo. Sige, ito, ganito gawin mo. Okay? You understand that? So, don't hesitate if you have a struggle in the activities and you want some help. Message me. Oh, problema yon. Okay? Exchange gift tayo. No? Christmas break, no? So, may exchange gift tayo. No, joke. Mag-ano tayo? Mag-discuss tayo. It's fine with me. It's absolutely fine with me. Here to help. I'll be happy to help. Okay?
Thanks, ma'am.
Yung deal natin I don't mind if you message me during the Christmas break. Minsan matagal lang akong sumagot kasi baka nasa labas kami. Pero I see it, kulitin niyo lang ako. Sige, fine. Kita tayo. Gusto niyo mag-usap kayong tatlo para isang usapan lang Ma'am, pwede niyo po ba kaming i-meet ng kayo? Okay lang sa akin yan. Kasi baka mag-ulit-ulit yung sasabihin ko Prepare pala kayo ng questions. Buti na yung prepare ko kayong i-meet. Bahala kayo, basta just give me a message. I'll be happy to accommodate. Okay? Okay, bye guys. We're good. See you next year.
Thank you. Merry Christmas.
I'll wait for your message.
Merry Christmas po. Thank you po.
Ingat kayo Ingat dyan, Adi Carl. Ay ka lang, Carl.
Ingat din po, ma'am.
Enjoy. Bye.
Bye, ma'am.